Hey guys, I'm Pat Kelly. Okay, so what they want us to do is to find the quadratic model that would give us these terms for the sequence. Okay, so that means to start is that we will end up with an answer that will look like some kind of a sub n, and then the expression over there will be quadratic. So what I'm going to do is write x n squared plus y n plus z. So quadratic in the variable of n. Okay, so n is going to be the variable. The x, the y, and the z, those are numbers that we're going to solve for. Okay, so let's do that. Next thing I'll do is I'll recognize the three terms that they gave me. Those each have a specific value for n, and that's just the subscript for each. So n equals 0, n equals 1, and n equals 4. The way that I use those then is with this template, we'll take each of the terms and create an equation. Let me slide over here for that. So you're looking at this template, but for a sub n, let's start with the n of 0. We know that it equals 3. So the first equation I can come up with is that 3 equals, let's see what I'm doing is I'm following this formula, x times 0 squared. Again, n is 0 for this one. Plus y times 0 plus z. Okay? Next, I use the same template, but I go on to my next term and have a different n value. So this time my a sub 1, which I know is 3, gives me this equation. 3 equals x times 1 squared plus y times 1 plus z. And then the third piece of information they gave me was a sub 4. I look at the same template, but my n is 4. They tell me that a sub 4 equals 15, and I put a 4 in for n everywhere here. Okay. Y times 4 plus z. All right, now what you'll always end up with here then is a system of linear equations. In this case, 3 equations, 3 unknowns, which is typically going to be the case for quadratic. Now you want to solve these. For me, what I would definitely focus on first is this first equation. It's always so nice when they give us zeros. That should be your favorite number, by the way, 0, because it's so easy to work with. Because they gave me these zeros, look at this equation, z equals 3, right? All right, and then I use that for each of these two equations. Let's simplify each one, now knowing that z is 3. Okay, so I'm going to write each of these equations right next to it, but clean it up a little bit. 1 squared times x is just x plus y. And a little bit of algebra in my head is that z of 3 I subtract over. There's a 3 over there, so that's going to equal 0. In this equation, let's do something similar. 4 squared is 16 times x plus 4 times y, and that equals, z was 3, but let's throw it over to the other side. 15 take away 3 is 12. Okay, that's good. And from these two equations, we'll figure out what x and y are, but I'm actually even going to take that second equation. It seems to me that it's begging to be divided by 4. Okay, so let's divide this equation by 4, and we'll get 4x plus y equals 3. So now, grab even another color, I'm going to take this equation and subtract that equation. Okay, so subtract. And maybe I'm thinking upside down here. Hopefully you can do the subtraction upside down with me, because this is what I'm focusing on, is y subtract y is 0, so that's good. And 4x subtract x gives me 3x. And on the right side of the equal signs, 3 minus 0 is 3. You see how that gives you a nice answer for x pretty darn quickly. X equals 1. Now I'll figure out what y is. I'll choose right here to do that. Because if I know that x equals 1, and that plus y is supposed to equal 0, that tells me that y equals a minus 1. All right, good. Good warm and fuzzy feeling because we have x, we have y, and we have z. So let's slide back over here and get our final answer. A sub n equals, and I'm looking at this template but putting in my specific values for x, y, and z. X was 1, y was -1, and z was 3. And that's your model. Okay? Try some more on your own, and I know you'll do great.